So it's 9:05. Welcome everyone. Good morning, good afternoon, World Bank colleagues, H4D partners, and STEAM audience. On behalf of the World Bank, we want to welcome you to the webinar, Green Hydrogen Derivatives, Trends in Regulation, Standardization, and Certification. My name is Carolina Lopez Rocha, and I'm part of the team that is hosted within the World Bank, and it's the Hydrogen for Development Partnership. Today, we are having this webinar as part of the activities that the H4D, or Hydrogen for Development Partnership, is committed to deliver in order to secure knowledge sharing and capacity building that support the deployment of clean hydrogen in emerging markets and developing countries. In this session, we have the pleasure to host colleagues from IRENA who will present the key findings of an interesting report that focuses on the regulations, standards, and certification schemes of hydrogen derivatives, including low emissions ammonia, low emissions methanol, iron, and steel. In today's webinar, our two distinguished panelists will discuss the current trends and also the policy recommendations that will enable international alignment and facilitate global trade of hydrogen derivatives. This is extremely relevant for the World Bank and for all the colleagues here, as many of the countries that we work with have very important targets to deploy a full value hydrogen economy. The agenda for today's webinar encompasses a 45-minute presentation from our speakers, a 15-minute Q&A, and closing remarks by my colleague Michelle Halak. Without any further ado, then please allow me to introduce our two experts. Arno van den Bos is an analyst of green hydrogen energy and Power-to-X at IRENA's Innovation and Technology Center in Bonn, where he provides policy advice on the role of green hydrogen and its derivatives in the energy transition, focusing on technological innovation, sustainability certification, quality infrastructure, and sourcing of renewable CO2. Goran Kohar is part of the Innovation and End User Sector team at IRENA Innovation and Technology Center in Bonn. He focuses on research and analysis to identify emerging trends and opportunities for end-use sectors, particularly for industrial decarbonization. And without further ado, I give the floor to our colleagues, Karan and Arno. I kindly request everyone connected to mute their phones, and let's start this very interesting presentation. Thank you.
Thank you so much, Sylvia. I'd like to first express my gratitude to the SMAP and H4D partnership for the invitation to present IRENA's report. We look forward to the discussions ahead. Before diving into the presentation, allow me to briefly introduce IRENA. IRENA is an intergovernmental organization with 170 members and another 14 countries in the accession process. We support countries in their transition to a sustainable energy future and serve as the principal platform for international cooperation, a center of excellence, and a repository of policy, technology, resource, and financial knowledge on renewable energy. A bit of context for today's discussion on the role of hydrogen in the energy transition is crucial. Here you can see the breakdown of the final energy consumption by energy carriers in 2020 and 2050, according to IRENA's 1.5 degree scenario to meet the goals of the Paris Agreement. As you see today, fossil fuels dominate the picture. They account for roughly 2/3 of the final energy consumption, and electricity accounts for only 1/5 of the consumption. By 2050, the picture has to change significantly. Electricity becomes the main energy carrier, accounting for more than half of the total final energy consumption, driven mostly by the electrification of all forms of road transport, as well as a fraction of heat demand, both in industries and buildings. According to our 2023 scenario, hydrogen and e-fuels will account for 14% of the total final energy consumption, and the bulk of that hydrogen comes from renewable power. So as you can see that hydrogen's contribution is relatively modest in terms of overall share in the energy system. However, on the other hand, hydrogen will be essential in some key applications, including the decarbonization of key industrial commodities like ammonia and steel, and in transport, for instance, in international shipping and in aviation, or even providing flexibility through medium and long-term storage to manage power systems. So even if we focus on these key applications for which hydrogen is needed, uh, we have ahead of ourselves a major challenge to scale production at the pace that we will need. First of all, we need to understand that today hydrogen is still a source of emissions. It is not a decarbonization vector yet. We produce about 100 million tons of hydrogen globally, and almost all of that is produced with fossil fuels with unabated emissions. By 2050, we need to scale that production more than fivefold while making sure that the majority of the hydrogen is green. Just to give you a sense of scale, by 2050, for the production of hydrogen and derivatives, we will need roughly as much electricity as the world consumes today for all purposes, which is roughly equivalent to 2100 terawatt hours. In terms of scaling up electrolysis, the order is around three orders of magnitude, from roughly 1 gigawatt today to 5,700 gigawatt by 2050. Therefore, we advise policymakers to be very selective in prioritizing those applications where hydrogen adds the most value. One key question is whether hydrogen can become cost competitive. And the answer is yes. If the deployment of renewable capacity and electrolyzer capacity happens at the pace and scale needed in a 1.5-degree scenario, then we can see cost reductions which are driven by technological learning, economies of scale, and optimization of supply chain. Under such scenario, we see hydrogen competing with fossil fuel-based hydrogen by the end of this decade in the best locations for renewable energy. Another good news is that the cost of renewables is going down fast. Solar and wind today are the cheapest options to produce power in most markets around the world. Increasingly, it is even cheaper to build new solar power plants than to continue operating existing fossil assets. We believe the world is in a much better position to adopt renewable energy technology and do so at a much faster pace than just a few years ago. First, by decarbonizing power supply, and then with that renewable power supply, decarbonizing end-use sectors through electrification, and also scaling the production of green hydrogen for the applications where it is needed most. Another key question is, where are these locations? To answer that, we use a GIS modeling system combining meteorological data, land eligibility criteria, for instance, protected areas, forest, and water stress, as well as key techno-economic parameters like the cost of capital, CapEx for these technologies. This helps us to determining where green hydrogen production can happen and at what cost. And you can see the results in this map, from which we can extract at least two key insights. The first is that unlike fossil fuels, renewable resources are very well distributed geographically. With fossil fuels, the top 5 countries control roughly two-thirds of the oil and gas reserves, respectively. That is not the case with renewables, and this will have implications for the overall potential trading volumes of green hydrogen and its derivatives. The second insight is that green hydrogen production can become very cost competitive with costs below $2 per kilogram in multiple locations in the most optimistic scenario. To explore how hydrogen trade might play out in the future, we have a global optimization model with a 2050 perspective. The resulting trade flows are shown in the map. Green represents green hydrogen and blue represents ammonia produced from green hydrogen. We estimate that about a quarter of the global hydrogen demand could be traded across borders. However, to put this in perspective, that's a quarter of the 14% of the energy system that we mentioned in the first slide. Of the hydrogen traded internationally by 2050, a bit more than half, roughly 55%, would be transported by pipeline, mostly retrofitting existing gas infrastructure or rights of way for natural gas infrastructure to reduce costs for neighboring countries. The other 45% would be shipped most likely as ammonia for use in fertilizers or shipping fuel and not reconverted back to hydrogen. In fact, we do not see significant volumes of hydrogen being shipped overseas as hydrogen. Instead, most hydrogen will be produced and consumed close to demand centers. It is important to consider that the physical characteristics of hydrogen make it technically difficult and economically costly to transport over long distances. Therefore, hydrogen trade will likely manifest more in trading commodities produced with hydrogen rather than hydrogen itself. These commodities include ammonia, methanol, iron, green iron, uh, or synthetic fuels, as the cost of transporting these is relatively small compared to transporting hydrogen and then producing these commodities. So this is a good segue to introduce the IRENA report. The report summarizes the status of regulations in first mover markets for these commodities that can be produced with hydrogen, um, along with standards and certification of hydrogen and those derivatives. And this helps evaluate bottlenecks and propose recommendations to enable the trade of these commodities. I will now pass the floor to my colleague Arno, who will present some of the key findings of the report before I return to present the recommendations. Thank you.
Thank you, Karan. And good morning, good afternoon, everyone who is here. So my name is Arno van der Bos. I work also at the Innovation and Technology Center in Bonn, together with Karan and a larger innovation and use team. And as Karan has shown, we expect most of the trade of hydrogen, so international trade of hydrogen, to happen in the form of derivatives. However, we also see that most of the focus of sustainability certification is actually focused on hydrogen itself. So what I'll do in this section is speak a little bit on what are the issues and the risks that these certification standards and sustainability certification schemes try to address, and how they differ, and how they do this in different ways. So these are some of the challenges for interoperability. And then we'll look a little bit at what conclusions we can draw from that. So if we go to the next slide. The screen is being shared indeed. So if we look, this is a typical supply chain of green hydrogen, also called electrolytic hydrogen. So we have at the center, at the core, we have the electrolyzer, which takes in water and electricity and produces hydrogen and oxygen, right? Now this has to be further compressed and transported to be used somewhere, or used locally. However, so typically the owner of this electrolyzer, all these emissions that happen there are either scope 1 or scope 2 from the electricity. But if we look upstream, so on the left, there are other emissions that could be caused by suppliers of either water or electricity to the water, or even the manufacturing of some of the components. And to the right, we have also downstream emissions that can happen from the transport, storage, and distribution, and in the end also by the end use of the product. So if the product is being used as a fuel, that will be emitted, it will generate emissions at the end. And if it's being used as a chemical product, then the emissions might happen at a later stage. So that already brings in some challenges that have to do with how the products are being used. But as you can see here, this supply chain can be broken down in different parts. And we have, if you click next, actually, I'll come back to the different stages and the scope. But first of all, some sustainability issues that happen or that need attention and that would need to be certified or demonstrated that they're dealt with properly are the source of water. So many, especially developing countries, have great solar and wind resources. However, water is sometimes abundant, but sometimes it's also scarce. And so there we see desalination playing an increasing large option. And one way of managing this that I've seen, which I think is a nice practice, is to share water treatment and desalination resources amongst different electrolyzer producers and hydrogen producers, and make sure that the capacity of the desalination is actually higher than the expected demand from electrolyzers, so that an excess can actually be made available for local populations, industries, or even agriculture. So I've seen this happen in northern countries in Northern Africa. I think there's several places in Latin America where this is happening as well. And another issue of water is that it's also needed for cooling. This is particularly important for gray hydrogen, but I'll come back to that in the next slide. If we look on the downstream, so if we click next, we'll have some issues that happen with emissions of electricity. So electricity is an important topic. I'll come back to this later, but essentially it's really important that the electricity that's being used is not only renewable, but that it doesn't create indirect effects, negative effects. So one of the concerns that are being addressed by European and US and increasingly other countries' policies are to ensure that the electricity generation capacity, whether it be solar, wind, hydro, or even biomass based, is not deviated from existing uses, right? So if you would have renewables being used for being sent to end users today, if tomorrow we say, no, now we're going to use this renewable electricity for powering electrolyzer, then the assumption is that whatever these other uses where electricity we're using before will have to be substituted, and that likely will happen by fossil generated energy in most power grids. Not everywhere, so this is not an issue everywhere, but this is mostly the case in countries that are in transition. And so those we call indirect effects that are undesirable. And to prevent that, policy usually use three principles called additionality, time matching or correlation, and geographic correlation. I'll come back to those in a minute. If we click next, we have on the downstream side. So on the top we have different points in our supply chain, also called the scope of the supply chain. So at the left we have the cradle, which usually corresponds to the extraction of resources. In this case, we discussed the water and even electricity in a way. And on the right, we have the gate. Now the gate, you have to be careful because sometimes gate refers to the gate of the production plant, and sometimes it refers to the gate of the end user or the entry point for the end use. And in between, there is transport and distribution, which may also create emissions. And so the question is, depending on how you define your scope, whether you will include those emissions or not. The arrow above shows a well to tank, which is a terminology that's used for transport fuels. So a lot of the European regulations were initially designed to ensure the sustainability of transport fuels. And so therefore it's useful that that sustainability is tracked all the way from the well, which is also the cradle, to the tank, which refers to the fuel tank of a vehicle. And then another way of measuring this, which is not shown here, is well to wheel, which takes additionally into account the efficiency of the engine in a car, for example, or a truck. So depending on how you define your scope and which ones of these elements you include in your life cycle assessment, which is the methodology that's used to measure the impact and on which we can set limits, you're going to get different results. And so this also means that you could have, for one particular installation in a particular country, if you use different methods that take into account different components or that have different scopes, you're going to get different results for life cycle emissions, or also called the carbon intensity of your fuel. So that's an important first aspect to consider. Now, if we go next, we'll dive in a little bit more about these electricity considerations. The well to wheel I already mentioned. So if we dive in a bit more into these sustainability principles for the renewable electricity that's used by an electrolyzer, the first point of additionality, I think I mentioned in a way that it has to be demonstrated that new renewable generation capacity has to be installed for the electrolyzer. So in the EU, they ask that you show that you don't use renewable capacity that's more than 2 years old. I think there's a specific date that it enters into generation. The second component, time matching, means that it's not only important where the electricity came from, but also at what time. If your electrolyzer is running at night or in the winter, then maybe your renewable generation asset is not generating during that time. So what's happening today in Europe, for example, is that because it's quite difficult to match these two initially, to allow for a fast deployment of installations, it's allowed that this matching happens only on a monthly basis, right? So you would still have to you cannot consume more with your electrolyzer that's been generated by the related assets during that month. And with time, this becomes more strict, and it is expected that in certain regions this will become have to be hourly matching. So really, you can only consume what has been demonstrably generated during the same hour, right? So in some areas, some industry organizations say that this increases the cost considerably. Other studies say that it doesn't really matter, and this depends a lot on how your power system is designed and what are their main components and how flexible they are, essentially. And the last point here is the deliverability, which refers to whether there exists a physical connection between your electrolyzer and your renewable asset. And so the first two conditions you might possibly address by having just certificates that are emitted. So demonstrate that somewhere at the same time your electricity is being generated. However, the last requirement of deliverability means that this electricity has to be injected into a grid or directly to the asset, but you cannot have it being generated somewhere where there's no physical connection. So not everyone requires this, but this is one of the requirements that is being translated in different ways in different legislations. So started with the EU, the US is adopting, they sometimes give them different names, but these are the same principles being adopted. Okay, let's go and look at a supply chain. And the next slide, please, for blue hydrogen. So blue hydrogen is generated at the core from steam reforming of methane. So methane, which is the main component of natural gas, of course, which is at the center. This may also require some electricity, and of course the steam, which requires energy. All of this generates emissions. And steam methane reforming generates hydrogen, but also CO2. Now, in the traditional gray hydrogen, this is being let escape into the air. And in blue hydrogen, this carbon dioxide is compressed and it's captured and it's stored in geological formations. However, this process is not perfect. So there are some limits to how much can be captured, and the capture rate actually changes and varies a lot from one installation to another. If we look on the left, if you maybe click the next in the slide, there's a few elements here. So in the scope, there's again the question of what components are included in the methodology for measuring the carbon intensity. One element that's not always taken into account is, for example, methane leakage that could happen from producing and transporting the natural gas towards the hydrogen production site. And so I would argue that it's important to at least measure that or at least take it into account. And if we look on the right-hand side, we have, I mentioned the CO2 that is normally captured. However, carbon capture rates range from, we've seen actually in a report, we've seen that this varies from sources that go all the way from 56 to about 90%. So that's a big difference. And this also affects significantly the total carbon footprint of the hydrogen. And last but not least, downstream, whatever hydrogen is produced needs to be stored and it needs to be transported, needs to be compressed. This consumes energy, and hydrogen itself could also be leaked. And even though hydrogen is not a greenhouse gas itself, it's not a direct greenhouse gas, it does actually produce indirect effects in the atmosphere where it interacts with gases that are greenhouse gases. And so it could actually has been demonstrated to have negative climate impacts if it's not controlled properly. So very important to measure this or take this into account. And then another point that I didn't mention on the slide, but is what data do we use for accounting for these all these emissions? And so some certification schemes and some standards and regulations require us to measure exactly how much is being emitted. So we use those primary data, while other standards and certification schemes allow us to use average data from the sector, and we call those secondary data sources. And so that's a big difference, because it means if you have an installation that doesn't capture CO2 very well and you're allowed to use average data from the industry, then there's little competition for improving CO2 capture rates, and also then it doesn't really stimulate improvements there, and also then your carbon footprint that you calculate is not going to be very reflecting exactly what's happening in the supply chain. So these are some of the issues for blue hydrogen. I already mentioned that blue hydrogen also consumes a lot of water, particularly for the cooling. And we've shown in other reports that this actually could be higher than for green hydrogen. So splitting water doesn't mean you actually use more water than when you're splitting natural gas. Okay, so these are some of the issues, and the different standards and methodologies, and then that have to be adopted by certification schemes, have to deal with. So if we go to the next slide. So there we come to, okay, how do we manage some of these risks, right? So of course, there are other risks. There are social risks. There are issues with other emissions of other materials. Another difference that we have in the tables is that some of the methodologies only measure the emissions of CO2. Others measure the emissions of methane and other greenhouse gases. So that's also a major difference between the methodologies. And so the methodologies are defined into standards, and so we define here a standard as a formal method or formal guidance that stipulates how and determines the characteristics of a system, and really these are methods that are particularly important for calculating greenhouse gas emissions. Often standards have been started on a voluntary basis, and then they get later made mandatory by regulations that say, okay, you have to use this standard to calculate greenhouse gas emissions, for example. And sometimes they are born as a mandate, and so they are mandatory from the beginning. And in the second column, we have certifications, and actually in the report refer to certification schemes. I know that in the US, the word scheme is usually associated with negative practices. This is not the case in the rest of the world. So a scheme is simply a system which has an owner, which is usually an NGO. It can be a government organization or even a private sector that decides together what the criteria are that should be included for determining whether something is sustainable. It determines which standards and methodologies are used for measuring it. But beyond that, it also decides on, and this is a second aspect, which has not so much to do with the sustainability criteria, but how do we provide a level of assurance, and how do we demonstrate that these criteria have been met, right? So in order to do that, the certification scheme comes up with requirements for the auditors, and the auditors have to be, or the certification companies that are hired to do the certification need to comply with certain standards themselves that can be and hopefully are accredited. So the accreditation organization is kind of an organization that certifies the certifier, right? That's one way I explain it. Maybe the certifies themselves don't like that term, but that's a way of understanding it. And so the certifications are determine what the process is for doing the assessment, which third parties are allowed to do it, under what conditions, what level of training they require, what understanding they have of the system, etc. And the certification scheme then, the certifier then emits a certificate at the end of the supply chain, and actually intermediate ones. So the certifier determines whether all the participants in the supply chain, as defined by the standard, actually meet the requirements and emits the certificate. Okay, so how do these look like now for hydrogen? So first we'll talk a little bit about hydrogen, and actually we that's what we've done here, and then later we'll see a little bit what additional considerations are required for some of the derivatives. And by derivatives, we mean ammonia, methanol, and green steel. And so I think some of the differences that happen between these standards and schemes, I mentioned the sustainability criteria that have to do with the sourcing of the electricity, or the renewable electricity in particular. Within the methodologies, I showed there are different scopes that can be covered. And so the scopes determine whether to include upstream emissions, for example, from transporting primary materials. This is particularly important if you transport, for example, LNG, which isn't happening on a large scale yet, but might happen in the future. Whether to include the methane emissions from producing first the natural gas and later the hydrogen. And so the ISO technical standard 1987-2023 actually includes them. And I'll come back to this one because this is a standard that hopes to bring a lot of these methodologies together. And whether to include emissions from transporting the product, so this is at a later stage of the supply chain, to the point of use, right? So therefore it's important, which gate are we talking about? Is it the output of the factory, or is it the input of an end user? And most jurisdictions will require well to gate, which is up to the point of production, whereas the EU requires actually well to the point of use, which means it needs to account for emissions that are generated from transporting the hydrogen to its end user. Another point important is whether to include emissions from leaks. And so leakage can happen in different locations, upstream and downstream. And another point is that I didn't mention is whether to include emissions from the capex, essentially from the equipment. So if I install an electrolyzer, should I include the emissions that were generated for producing the electrolyzer? And this ISO standard does, but some methodologies do not. And whether calculations require the use of primary versus secondary data sources, which I mentioned. And so secondary data sources are default values. So using default values has the advantage of making calculations a lot easier, because you can just look it up from a table that's approved by the jurisdiction. However, it means that some projects that are not very good or have higher emissions would effectively report lower emissions in reality, and vice versa. If you have a latest technology and that's very efficient and you have very low emissions, you're not going to get credit for that because you have to use these general data. All right. And the last point here is on the level of assurance. So this is really covered by the certification scheme. And one element there that the certification schemes determine is what tracking methodology is used for tracking your product through its supply chain. So there are essentially 4 methodologies, but the main ones used for hydrogen are mass balance. Mass balance means that you can mix sustainable hydrogen with non-sustainable hydrogen, or sustainable product with any non-sustainable product. But they have to come from a physically connected supply chain. So that requires a bit more work on the ground. Whereas book and claim, which is the other common option, basically emits a certificate wherever the hydrogen is produced, and then gets disconnected from the physical flow and can be emitted by an end user at the end. And so this just guarantees that some clean hydrogen has been produced somewhere, but maybe the hydrogen you're using doesn't contain any of those green molecules, right? And the last point is on accreditation that I mentioned, which has to do with requirements on the certification bodies and auditors. And so most countries have accreditation organizations that keep track of whether certification organizations meet the latest standards, and make sure that there are procedures for complaining if they don't do the job properly, and so that there's a feedback, and so that they improve the procedures. And the accreditors even have guidelines that are emitted by the ISEAL Alliance. So it is essentially emitting guidelines for accreditation bodies. And so these have all important roles in making sure that not only the methodologies for measuring sustainability are correct, but also that the processes for doing it are also standardized and meet minimum requirements. So all these things apply to hydrogen, and of course, because hydrogen is an input for the derivatives, all these things are relevant for all the derivatives. However, when we look at derivatives, there are also other considerations to take into account. So if we go to the next slide, please, where we show a table where we've looked at only one criteria, which is the emission threshold, so the carbon intensity that different jurisdictions allow for having access essentially to support for this product, right? So to give you an idea, in the EU, you can sell hydrogen that doesn't meet this requirement. However, then it doesn't meet the criteria as being green hydrogen, and therefore it will not count towards the green hydrogen targets, and you're not going to get any support from the EU countries. And so first observation is that for hydrogen, there's a lot of differences between what thresholds countries consider as the maximum emission for a kilogram of hydrogen. And I think this is really has to do with the sovereignty of the jurisdictions that create these markets, right? So all these jurisdictions put in place either subsidies or obligated markets and targets that have to be met. And so if you're going to provide support for these markets, it makes sense that you decide on what you consider to be sustainable. However, the other issue there is, as I discussed before, is that how do you measure this? And so sometimes we call this the measuring stick. And so if you want to sell hydrogen in one jurisdiction that requires a certain methodology, the hydrogen produced from the same plant might end up with a different number than if being sold in another jurisdiction, right? Just because they measure it in a different way. So I think this is a first area where alignment or at least interoperability is desired. And so this is where there are efforts to make sure that all these schemes and jurisdictions and laws recognize and use the same methodologies for calculating the carbon footprint of these products. And the second observation here is that we see that for ammonia, methanol, iron, and steel, there's a lot less required by governments, right? So what we see is that a lot of the initiatives are actually come from the private sector that come up with voluntary guidelines and standards. However, governments are lagging behind. And this is a challenge because, as my colleague Karen mentioned earlier, we expect most of the trade, at least international trade, to happen in the form of these derivatives. So if we really want to import ammonia and methanol and ship it around the world, we need to make sure that the certification or that it can meet requirements which need to be in place, and also that there's clarity there to be able to kickstart this trade at an international level. So if we go to the next slide, please. So very quickly, this is for, we have shown here a list of standards and methodologies. Many are from the ISO, but there are many other methodologies that have been determined, either that come from voluntary areas of the private sector, others that come from other countries like Germany and China that have their own systems. And on the right, we have certification schemes. So again, certification systems that use these methodologies and that usually actually set a minimum threshold and that demonstrate compliance with these minimum sustainability requirements. Now, the list that we have here changes all the time, right? So some of these tables that we have, you have to bear in mind that this is a good starting point for a discussion, but this is a dynamic sector, so they may not be up to date very soon. And if we look at the next slide, we look at what's happening in the area of derivatives. So here we have on the top left, we have the different standards and methodologies for ammonia combined with different certifications. On the right, we have standards and certification initiatives for iron and steel. And at the bottom, we have them for methanol. So if we go to the next slide. So in our report, we have made for each of these derivatives. So we have made this for hydrogen, but we've also done this for each of the derivatives. We've created tables where we say first on the standards and methodologies, and then second for the certification schemes. We've tried to compare them, right? So this is really putting out there how do these methodologies and systems work, so they are made comparable. So this is a first step, at least in the transparency, in making sure what you get. And I wanted to take you a little bit through the headers of this table. So the boundary I explained already when I talked about hydrogen, but what happens when you deal with methanol and even ammonia is that a lot of these boundaries initially were set for fuels, but if you use, say, methanol as a chemical input for making plastics or high value chemicals and then plastics, then of course the scope of your system actually gets expanded towards downstream, right? Because you have a plastic that will be used and that might end up in either be recycled or be burned, etc. So the boundary might expand. Second, the pollutants that are covered, sometimes it's all greenhouse gases, sometimes it's just CO2. So there's a major difference there. The emission thresholds we discussed. And for one specific criteria that's relevant for methanol is that if we speak about, so methanol can be produced biologically, so we call it biomethanol, but in the context of hydrogen, we talk about e-methanol. So e-methanol is is the result of a synthesis process of green hydrogen combined with a renewable form of carbon, because methanol contains carbon, and if we want to have sustainable methanol, the carbon also needs to be sustainable. And there the question is, where does this carbon come from? Today, many plants capture CO2 from fossil generation plants, and they combine this with green hydrogen to make methanol. However, the carbon in there actually came from a fossil fuel originally, and therefore is not renewable. So the forms of renewable carbon are biogenic CO2. So this is CO2 that comes from burning combustion of biomass, for example, or as a result of fermentation. So when you produce ethanol, there's a lot of CO2 that gets emitted there, but this is CO2 that came from the plant, so it's short cycle CO2, and therefore it's renewable. And so one thing that we are saying here is that, first of all, countries need to be aware of what their sources of biogenic CO2 are. The high concentration sources, such as the ones from fermentation, are not very large, and so they will probably run out quickly. So it makes sense to go and study what you have available locally. For project developers, you need to make sure you don't have only access to renewables, hydrogen and water, but also to sustainable carbon. Because the other option, which is unlimited of renewable carbon, is from direct air capture, right? So this is taking the air with very low concentrations of CO2, compressing it and extracting the CO2, but this is very energy intensive and therefore very expensive. And therefore it makes probably producing methanol uncompetitive in the medium term. So those are really considerations for country policies and for project developers. For certification schemes, it's essentially important to track the origin of CO2 and also determine whether it might have actually a carbon footprint. So once you start compressing CO2, you might have to pump it through pipelines, or you might put it on a truck, etc. So then there are emissions created to transport your CO2 that might be renewable, but you might still have emissions there. So these are all considerations for certification schemes that are not being taken into account very much yet. And sorry, if we can go one back, because there was a couple of more other considerations for the stand. Yes. So no, the table for for standards. Thank you. So those were the requirements on the source of carbon. And then the last three ones have to do with giving credits, and these have to do with allocation methodologies that you use in life cycle assessment. So if you have a process that generates one product, you say all the upstream emissions are caused by this product, right? So it's very easy to say there were so many kilos of CO2 per kilo of hydrogen. However, if you have co-products being generated, then you have to allocate the upstream emissions amongst the different co-products. So co-products are generated, for example, when you produce ammonia, which does produce actually a little bit of methanol and also some N2O and NO2. And so if you emit those into the atmosphere, those are emissions you need to account for in your into your ammonia. However, if you because they are such high concentrations, you might also be able to sell those products. And those products also could carry part of the responsibility for the emissions that happened upstream. And so whether your certification scheme recognizes that, which is the allotted export of byproducts, is something that needs to be transparent and is not always the case. So you can export, you can have co-products. A similar allocation issue happens when you export leftover energy, right? If you're producing a lot of heat, you might be able to sell that to a neighbor, and that energy should carry part of the responsibility for the upstream emissions. And finally, allotted offsets basically determines whether, as a producer of ammonia, methanol, and even green steel, you are allowed to compensate for some of those emissions with offsets, right? So offsets could be carbon removals or carbon permits from a certain carbon market. And these may or may not be included in the methodology for measuring your carbon footprint. And of course, they will change the carbon footprint for a same production line with different methodologies. You're going to get different numbers there. So all these issues are relevant for both ammonia. The carbon is only for methanol, and the allocation is really relevant for all three, both ammonia, methanol, and iron and steel. And so we provide in a report a table where you can see what the name is of the organization that leads the methodologies or the certification scheme. So this was about the methodology, and now we can go to the schemes or the systems. So the boundary here is shown as showing the upstream, midstream, and downstream emissions. Orange means that it is partially covered, and gray means that it's not covered. And so some of the certification schemes have a particular threshold in them, others do not. There's differences in how long a certificate is valid for. So certain schemes require a reissue of certificate every year. Others allow you to keep it for up to 5 years. Some of them do mention or do require you to demonstrate the source of your carbon. Others do not. And finally, the chain of custody model used, which is also true for hydrogen, and whether products are allowed to be blended or not, or whether they have to be kept separate. Okay, that's a lot of technical talk. Let's go to the next slide. And we can come back if there's specific questions on some of these aspects. Can come back to those, and I will leave Karan with the honor of providing some conclusions and recommendations.
Thank you so much, Arno. So the analysis that we conducted as a part of this report reveals two main findings. First is the development of regulations or thresholds for hydrogen derivatives lags behind hydrogens. We saw that from the table at the start of the section. And from the tables in the latter half, we see that the standard certifications, even regulations or thresholds to be specific for hydrogen and its derivatives reveal different degrees of heterogeneity. And working on these issues require efforts on three main fronts, which I will discuss in the next few slides. So first of all, as I mentioned in the introductory slides, that due to the physical characteristics of hydrogen, green hydrogen trade will likely manifest more in trading commodities produced with hydrogen, such as ammonia, iron and steel, methanol, or synthetic fuel. This is because the cost of transporting these is relatively small compared to transporting hydrogen and then producing these commodities. The production of these commodities can consume significant amounts of hydrogen in their production. For example, stoichiometrically, ammonia, methanol can consume around 200 kilograms of hydrogen to produce 1 ton of ammonia or methanol. DRI with hydrogen would also need around 50 to 100 kilograms per ton of DRI, depending on how you're heating. So there is a bit of uncertainty on that also. And the market for these commodities is already in the thousands or millions of tons a year. So it's not hard to imagine how much low emissions hydrogen we would need to produce these derivatives. When such quantities of hydrogen are being used, it is important to make sure that the regulations that are being developed for hydrogen are passed through to the derivative commodities as well. In That is in addition to the other requirements that the derivatives may already have. For example, sourcing of carbon that Arno spoke about. Next, so the other side of the coin is the development of standards and certifications for derivatives and hydrogen. But this is especially true for derivatives because the market for these derivatives is in infancy; it's still developing. So there is a need that these initiatives are clear, specific, and transparent in highlighting the requirements of different markets, either voluntary or mandatory. One way to do this is to develop these initiatives in consultation with different supply chain actors, especially in those export markets. Would-be suppliers and certifiers could also engage in pre-certification exercises during an early stage of the certification process. There, they can assess how they would need to adapt internal processes to comply with these schemes because that can take some time. And we've already seen some pre-certification trials for renewable hydrogen projects, and such could also be replicated for the derivatives as well. And lastly, so the report discusses different requirements between regulatory standards and certification schemes that extend beyond the scope to talking about how they allot credit, what other requirements are for derivatives. So essentially, we're talking about different measuring sticks to measure different things. And Arno had mentioned that even though there are good reasons for these heterogeneities, for example, through nationally determined or locally appropriate objectives, it is important that these initiatives for green hydrogen and derivatives be aligned as far as possible. Agreement to develop common standards, for example, steel standard principles, could also provide a model. The willingness to collaborate was also shown by the COP28 agreement on hydrogen, which indicates a global momentum and will. Wherever alignment is not feasible, mutual recognition can help harmonize standards and facilitate global trade in these vital commodities. The report highlights these differences and similarities between standards and certification schemes, which could also help on mutual recognition. And lastly, IRENA's collaborative framework on green hydrogen, along with platforms like the IPHE, the International Hydrogen Trade Forum, and IEA's Technology Collaboration Program, can play a key role in coordinating efforts to harmonize these framework and ensure mutual recognition. Thank you so much to everyone for listening. And the report is available on our website. You can download it directly from there, or you can use the QR code below below the text to download it. Thank you.
Thank you, Arno. Thank you, Karam, for this presentation. It's been really interesting to learn more about this and also for the report. Kudos on that. I think we have some questions already in the chat. For instance, Ibrahim have a question regarding, are the scope emission only for carbon or also for hydrogen on warming potential or impact via leakage? And secondly, we have another question that says, what is your view on European Low Carbon Hydrogen Delegated Act and its impact on importing ammonia? And lastly, we have another comment so far that says that the green hydrogen standard is not a standard itself. It's a private initiative only, not open to the public, just FYI. So if you can.
Do you want to go first?
Sure. Well, the scope of emissions, as I mentioned, can apply. It depends on the methodologies and on the schemes. So for some of them, they only look at CO2, and for others, they look at other greenhouse gases. And of course, hydrogen, as I mentioned, also has an indirect greenhouse gas impact, which is only recently starting to be understood. So there's not so much alignment on what the numbers actually are. There's a couple of studies there. So it's a bit of a challenge, but these are underway. And perhaps a broader comment on this is that these standards and systems are in evolution, right? So each country is making adjustments. Sometimes they add components. Sometimes they extend the scope. And one of the general recommendations we always make is, as countries and NGOs and companies, make sure that you're part of these discussions, right? So that your voice is heard, and thresholds can be changed. Hopefully they are not changed every few years, because investors need security for their investments. But in the long term, there is potential change there. A view on the EU Low Carbon Hydrogen Delegated Act. So there's two delegated acts, but impact on imported ammonia. I am not sure about which one in particular, but for example, currently there is an opening for providing comments on a delegated act about, actually this is for blue RFNBOs, right? So blue ammonia, but it would also be true for blue hydrogen. And so there, a proposal is made to allow secondary data sources for emissions from blue hydrogen until 2027, and there is no concrete proposal for what it should be after that. So I think this presents a number of challenges because it eliminates the competition between companies that do better than average. And it also means that it's difficult to make investments if you don't know how you will be judged and whether you will meet the requirements after 27. So I think these are some of the views I saw on the website. But I don't know if the question was about this in particular or more general. The other one was about CBAM. So CBAM is the Carbon Border Adjustment Mechanism. So this is really a mechanism that has been discussed for decades. I remember when I was studying, the concept was around, but now it's actually been implemented, and it's implemented for ever more components. So the idea is that a producer in this case is for the EU. So a producer in the EU has to buy carbon credits for their emissions. However, if someone imports from another country, they don't have to comply with regulations, which mean they might be able to produce it at a lower cost. And so to level the playing field, we say, well, if you import it and you emitted so many emissions, then you're going to have to pay for that, and you have to pay for. But so this applies for hydrogen that doesn't necessarily comply with all the green requirements. So this is just to compete with the gray version. And there may be other implications. I don't know, Karen, if you wanted to come in on that.
Maybe I think from a broader perspective, CBAM is much broader. It covers imports under certain sectors that are coming into the EU, while the delegated acts under the RED scheme is for fuels or commodities that will be used to achieve member country targets. So that's the big difference between them. There are some commodities, for example, hydrogen and ammonia, which are applicable to both CBAM and the delegated acts. We have mentioned in the report that there are some commonalities in both, but ultimately navigating the differences for producers, for suppliers, for these commodities which are applicable to both is going to be a little bit tough, and it could be a little bit tough, and efforts are needed to harmonize these initiatives. For example, for renewable hydrogen that is compliant with RED, zero emissions are allocated under CBAM, so there is some harmonization already. But in terms of scope, in terms of in terms of the measuring stick, more efforts could be used to harmonize it for the derivative commodities also.
Okay. Was there another question that we missed?
Yes. We have another one from our colleagues from H2 Peru, for example, that says, who should take or would be better prepared to lead the harmonization, or it would be better to leave as it to supply will follow demand?
Yes, good question. So harmonization is I would say it's an ambitious word. I think so. On the one side, it is okay. Different jurisdictions might have different criteria. I think that's unlikely to change in the short term. The other issue where I think we really want to see some harmonization is at least using the same measuring stick, right? So using the same methodologies for finding out what your carbon input is, your carbon emissions are over a life cycle. So there are different initiatives that are working on this. So last year at the COP, Karen mentioned there was a declaration of intent that was signed by about 40 countries that say they want to work together in a collaborative way to develop and recognize methodologies. This is still happening. So I think what we're seeing now, there's a bit of a shift from alignment to interoperability, because there's a recognition, first of all, that some of these criteria will not be aligned, but that the methodologies may be able to do that. So the International Standards Organization has taken up this this methodology 1980 2023, which is now being developed into more specific methodologies for also for liquid hydrogen, for methanol, and for I forgot which the third one was. There is a technical working group also led by the IEA that tries to work on these. And I imagine, I expect at the next COP there will be more declarations that might go a bit more beyond the intent, but yeah, we'll have to wait and see. But I think this is the path that's being adopted, is to agree at least on the methodologies. And then the other thing that is happening already is that certification schemes can choose to recognize these different methods, right? So you could have, so we already see there's an IECC EU. There's a very possible that tomorrow there might be an IECC Japan, right? So I'm not saying that this will happen or they will do this, but essentially have a scheme and you know which market it will address. And I think the schemes amongst each other would also do well to sort of recognize amongst each other the sort of auditing work, provided it complies with the same quality criteria, to avoid having 3 auditors coming into your company if you want to address 3 different markets, right? I think that's a risk. But as I said, this is changing. One thing I would say is, for example, the technical committee of the ISO that sets these international methodologies today only has 26 members countries. So I highly encourage, especially developing countries, to be on those committees so that their interests are also heard and hopefully taken into account. And this is the case in many normalization and standardization processes, where we often see that there's an overweight from industrialized countries. And so, yes, this is also an important recommendation there.
Thank you, Arno, for this. We have 2 more questions in the chat, and then we can leave the floor to Hiro. We have one from our colleague Margaret Monique that says, what are the views on the EU Delegated Act on renewable hydrogen on countries looking to export to Europe, specifically African countries? And another question from our colleague Carolina that says, what would you say are the most difficult challenges related to ammonia certification?
Okay, again, the first one on the delegated acts on renewables on countries looking to export to Europe, they're facing many challenges. Some of them have to do with local acceptance of renewables, of water, etc. But in terms of certifying to European standards, one of them is essentially understanding how these things work. So from the EU perspective, demonstrating compliance with additionality basically are given 3 options, right? One is if you have a grid that's 90% renewable, then you automatically comply, but that's not the case for almost no European countries and none of the North African countries. And the other one is if you just connect it directly in island mode from a renewable to your electrolyzer, and that's a way relatively easy to demonstrate that you meet this requirement. And the third way, which is more complicated, is that you have to demonstrate that the energy that you consume has been injected somewhere else in the grid at the same time. And so there's this physical and time matching requirements. These are much more difficult to meet. And so some countries are working on guarantees of origin for electricity that might meet those requirements. The EU also discusses these load zones, or there's actually another name there, which is difficult to translate into some of these countries. And well, based on my recent discussions with a few North African countries, I think a lot of projects simply go for the island mode because they know that this will work. It gives them certainty. But then this also means that the sustainability requirements might lead, and so this would have to be modeled to give a definite answer there, but there's a possibility that electrolyzers could actually also play a positive role in helping to integrate renewables into the grid, and this might not happen because of the sustainability requirements, right? So this is something that I think requires a bit more analysis. It will differ from one country to another, so I don't want to make generalizations here. Yes, I think the knowledge and understanding the requirements is also a challenge there, and therefore collaboration, capacity building are of course keys.
Maybe one point to add.
Yeah.
Sorry, yeah. Maybe one point to add, not generally for the EU, but specifically for countries with import requirements, is that they should also consider the impact of these regulations on renewable energy development from the exporting countries. And this could be particularly true for developing countries as well.
And then there was this question on the most difficult challenges for ammonia certification. I don't know, Karen, if you want to.
I mean, there could be plenty of challenges. Plenty of challenges. We have discussed methanol in the presentation. The same also applies to ammonia. If you go through the report in the table, you can already the findings that we spoke about for methanol are also applicable to ammonia, that there is heterogeneity between different standards and certification schemes. And again, the challenges would depend on the export market and the regulations in the import market, and how these certification schemes would aim to solve it. But I think it's a very subjective question.
Yeah, so the schemes themselves are still in evolution and still being developed. And beside the sourcing of your hydrogen, you have all these issues that have to do with perhaps getting extra credit for co-products and offsets, and these things I think are quite challenging. But and on the other side, it's a market that already, so the whole infrastructure is well known. So maybe that's an advantage, that it's not a new sector. I mean, the ammonia sector exists as such. It's just the renewable ammonia is new. And so how you track it through the supply chains large part of the supply chains will remain the same. But the certification needs a bit more guidance, I think, particularly from governments that have left most of this work to the private sector so far.
Thank you both for those answers. Hiro, please.
Yes. Yeah. Thank you for the opportunity, and then yeah, thank you so much for the comprehensive explanation by IRENA colleagues. I'm Hiroaki from the World Bank, Senior Program Officer. So my question is that so how do you want to us, or people, to utilize the certification? It is because that I do understand that ideally we seek for the cleaner, or the greener hydrogen or ammonia, but now we are under the transition process, so that's why maybe we have to be realistic to accept some hydrogen which is not perfectly pure clean hydrogen. For example, let me explain some examples. So when I talk with Indian government or Indian companies, so there is a difficulty how to measure the, how can you say, the cleanness of the CO2, because they sometimes want to use the grid, and then the the electricity of the from their coal, and then the green is mix, contaminated. This is the first, example. And the second example is that, when we see the, the US IRA, the green hydrogen, the support, of course, they have a huge support for the green hydrogen or clean hydrogen by the 45V. But since this, criteria is too strict, including additionality is too hard for the company, so many of them abandon, to seek for the 45V. Rather, they seek for 45Q, which focus on the CCS support rather than the green hydrogen support. So again, I do understand in the long run, this certification must be very important. But I'm asking that in the short run, so how do you think, your activities or our activities should be utilized, recognized by the companies? Thank you so much.
Yeah, I think those are good questions. I think you're showing that putting in place major new policies always comes with a learning process. Maybe on the Indian example, let's say no, maybe our electricity is not 100% renewable, and we may start using electricity that's not renewable. So that's also why countries have different requirements on what they understand by sustainable, right? Maybe for one country, having a 50% emission reduction compared to standard ammonia is already enough of an improvement within the context of their national decarbonization plans and maybe net zero program. It depends what happens in other sectors and so forth. So if an Indian consumer is fine with having ammonia, which provides a little bit of improvement compared to gray ammonia, that's their decision, right? I think so. One thing is first of all, it's important to kind of agree on how you measure it, because then it's easy for someone who makes electrolyzers or ammonia synthesis plants to go and sell their equipment and make pre-calculations for what this will look like in terms of emissions. So again, the methodologies, it's very valuable and useful to align them. In terms of support for ammonia, and effectively the IRA has been designed really as an industry policy to try to produce as much of it locally and develop the technology locally. Some companies might change their strategy, because I think they're still. I think on the one side, there's still a bit of uncertainty as to how this will be measured, right? So they have this threshold set, but there's still a bit of indecision on how this will exactly be measured. So I think that's one barrier, at least slows it down a little bit. And on the other hand, companies will make their own assessments of what makes sense in my jurisdiction, and maybe it will be impossible for them under economic circumstances to meet some of these most strict requirements, and that's fine. And if that becomes a major issue in the US, then I can expect that the policy might change at some stage. But I think it's a bit early for that. I think we first need to get some experience. But I'm not an expert on the US market as such, but I'm happy to keep that discussion going. And yeah, the support of CCS is I think it looked less attractive initially, but of course but I would just highlight what we mentioned earlier, is that carbon capture is also a relatively immature technology that has risks of some CO2 leakage, and the capture is never 100%. So it's not, from an environmental perspective, it has risks, but if it's done well, and I think there's examples perhaps in Norway or in a certain amount of jurisdictions where relatively high capture rates can be obtained, and that might just do the job, right? So, yeah.
Thank you so much.
Dear Arno, Karam, we have two last questions from the JZ, Colombia and Chile. From the JZ Colombia, the question is on the study you analyzed the EU certification and CBAM. Could you explain a bit more about how do you think this could evolve with CBAM products, for instance, hydrogen fertilizers, steel, and the final products they use, for instance, vehicles or agricultural products, etc.? And from the Chilean side, we have the question from Gustavo that says, if one intends to export hydrogen or its derivatives, should there be a certification of the production, and does certification need to be consistent with the country of destination? In other words, is a double certification required?
Arno, maybe I can take the first one, and then you can take the and then if you want to add something, and
Sure, go
then
ahead.
you can
Go
take
ahead.
this. So yeah, I think that was a good point good question about CBAM and the delegated acts. So there is a section in the report that tries to explain the differences between the two scheme. As I said earlier, it looks like on the surface level, it looks like they're competing for commodities that fall into both categories or both schemes. But the idea is that they are intended for different purposes, and the recommendation is that ultimately post the transitional phase of the CBAM, um, the CBAM, the delegated act, the requirements under the both schemes align as much as possible. Um, if not possible, there could be certification schemes that could perhaps enable um, use for both use under both schemes. I hope that answers the question.
And I think maybe the question on whether this will extend to other products, such as cars or things that include them, I think that's a good question. I don't have the answer. I think these are long political discussions, essentially. So I don't know if there's plans for these. So I'm afraid I don't know the answer. On the question of if you want to export derivatives from Chile or from anywhere else, you need to demonstrate to the destination market that they comply with their requirements. If you are exporting ammonia, then you should only have to demonstrate that the ammonia is made sustainably. However, the ammonia certification will include all of those aspects that were discussed for hydrogen anyway, right? So it will not be a hydrogen certification, but and what we're seeing is that hydrogen certification schemes are adapting and expanding their coverage to include ammonia, right? So we're fairly early stages, but this is happening. So I would say only one certification would be enough per destination market.
Thank you both for those comments. Michelle, please, the floor is all yours.
Thank you very much. First of all, I just want to thank you, Arno and Karen, for this great presentation, as also great discussion, because we see that's a topic that raises a lot of discussion and issues. And I will not conclude because I guess you already did it. I just want to bring a little bit back the title of the report, and also to invite people to read and think a little bit about that, because you're trying to think about the trade, right? How the trade can change this hydrogen market, right? Right now, we don't have a green hydrogen market. We don't have a green hydrogen price, even nationally and much less internationally. So if you think about 2050, should we think that it will happen? It will have a price. We will have a green hydrogen or derivative market internationally, that we can have a price, that can do contracts based on this price. Because if you have a price that it's international, there is an international benchmark, most of the contracts and how we can the risk, the contracts change, and it's facilitated because we can have market mechanism to do so, right? So I guess that's how the reflection I think that this report brought to me. And just to raise one of the points that you have raised, that you show that 14%, 14% of the total energy consumption is expected to be by hydrogen and hydrogen derivatives by 2050. This is a lot. Even if it's not, let's say, a big chunk of, let's say it's not 50%, it's a big part of the energy market. And as you said, this means in electricity, the demand of electricity we have now. So I would say, even if it's optimist, let's say, even if it's half of it, it's still huge in terms of the amount of investment that we need to have, in terms of the decisions that need to be made in the next years to be able to arrive in this topic of 2050. So I guess that's for me one of the big marks of that. And then you said, look, 25% of it should be traded internationally, and more than that, 45% of it should be done by ships. If you compare it with the natural gas market today and the role of LNG that bring us a price, right? Even if it's not the same, but changed completely how the natural gas market work. When you have a hub and you have an international price, this can bring a big revolution on the energy market and how it is related, because most of it, as you mentioned, it will be done by electricity. So it's a way to connect electricity markets in somehow, right? So that's a big change on what we see. But then I think what brings us the reflection that all the discussion of standards and that said it would be possible to have one product. We will be able to have something that you have a price, or you have comparative price that you're able to use it as a benchmark of international trade. I guess this is still a big question for all of us after reading the report and hearing you here, because as you said, there is a lot of different elements on the standards, and there is a trade-off. If you harmonize the standards, you are decreasing the specificities, and also you may make it more difficult to be sure of the decrease of the CO2 emissions, that in the end, it's one of the main goals. If you do something really specific, and as you mentioned, specific country by country, as it was discussed in the case of India, taking in account the country's elements and pathways, it will be really hard to make this as a tradable product that you can have a unified price. So I think it brings a lot of food for thought, a lot of information and knowledge, but also a lot of food for thought in the sense of what's the direction of the clean hydrogen market you'll be taking in the following years, and what's the role that these standards and also the international community will play on bringing an international market, or make it regional or country by country. I think it talk a lot about how these standards will be discussed and negotiated and move forward. And I think the work that has been done that you mentioned, it's really important on that issue, because if you don't dialogue and don't understand the trade-offs of choosing one thing and the other, you may losing some opportunities here, right? So with this few reflection on the report, I invite everybody to take a look on that, because it brings a lot of information and knowledge for us. And I hope we can have another opportunity to go deeper on this discussion and look ahead on how it will be the next steps on this market. Thank you very much.
Yes, that's a lot of good points. I'll make just a couple of points, because I know we're running kind of out of time, and I'm seeing also the comments here. So, of course, if you look at the oil and gas, so for oil we have the Brent, which is basically a price, the market where different providers and buyers know what type of oil they're getting. You have in the US, you have the West Texas Intermediate, which basically is a contract that comes with a volume and chemical characteristics of what you're buying, right? And delivery options and who's responsible at what point. These things exist for ammonia, at least for gray ammonia, and for methanol. These markets are already there. Now the question is, to what extent, or what's required to make this happen for green ammonia, or renewable ammonia, and for green methanol, etc. So I think some of these are starting to appear for ammonia and for methanol, but and of course, the quality that we care about for ammonia and methanol is not the molecules, because they're all the same. It's the sustainability characteristics, and this is where this discussion we had today is used and feeds as an input. And yes, it exists for green ammonia as futures. I see Mika is mentioning. So we haven't dived into that sector, but there is markets there, and so they might appear for Europe. They might be there for Singapore, some of the biggest markets. And I also recently was made aware there is a Zero Emissions Traders Alliance that's actually working on making this happen. So that's probably a next step. I think agreement on methodologies for measuring characteristics is part of it. And then, of course, the trade will indeed require standard, or it will be facilitated a lot by standard contracts. It's not necessarily a requirement. These things can also be done on a peer-to-peer basis, which is what's happening a lot now.
Thank you very much. I know that's kind of simplification, but the idea is that if you have more standardized, you have price that fits to more kind of contracts. I guess that's the idea here. And,
yes.
And we know that it facilitates the trade, right, and the value. So thank you very much. And as you said, I guess it's a next step discussion, but yeah, I think it brings some reflection to us. Thank you very much.
Thank you so much.
Thank you.
Thank you.
Thank you very much, Arno, Karam, Michelle, and Carolina, for your time in this session. I think we are more than finished today. So thank you all for joining our colleagues, and this concludes our session. Thank you.
Thank you all. Bye-bye.
Thank you. Take care.
Thank you.
Bye.
Bye.